You ever wonder how your streaming service just knows what movie you want to watch next? Or how some app on your phone can predict traffic down to the minute? Well, that's the magic of data science. And yeah, it sounds super complex, but today we're going to break it all down. We're going to see how we can go from a whole mess of information to predicting something we all care about, the price of a good pizza.
So first, let me ask you something. Just think about your day so far, from the second you woke up. How many times do you think you've actually created data? You might be thinking, maybe once or twice, but honestly, you'd be amazed. The truth is, we're all constantly creating this tidal wave of data, a lot of the time without even thinking about it.
You know that smartwatch on your wrist counting your steps? Yep, that's data. The text message you just fired off, the ride you called to get to work, the lunch you ordered online, it's all data. We are absolutely swimming in it, creating these digital breadcrumbs with almost everything we do. So, what's the point of all this stuff?
Well, that is where data science steps in. It's basically the art of taking all that raw, messy data and finding the hidden gems inside. The valuable insights that help companies make smarter decisions, spot trends, and, just understand the world a whole lot better. Okay, so how do you get from that giant pile of data to a clear, useful insight? It's not magic, not at all. It's actually a pretty structured journey. The best way to think about it is like a roadmap that guides you from point A, the problem, all the way to your destination.
And here's that roadmap. Pretty much every data science project follows these same core steps. You always start by understanding the goal, like what question are we really trying to answer here? Then you go out and collect the info. And this next part is absolutely crucial. You have to clean it because real-world data is, well, it's messy. It's full of mistakes and gaps. Only then can you get to the fun part, building a model to find those patterns, and finally, turning them into insights you can actually see and understand.
For our little journey today, we're going to zoom in on what I think is the coolest part, Step 4, building a model. This is where it feels like the magic happens. And one of the most common ways to do this is with a technique called supervised learning.
Now, supervised learning might sound pretty technical, but the idea behind it is incredibly simple. Seriously, it's just like teaching a computer how to do something by showing it tons and tons of examples. The key, the secret sauce, is that this data is labeled, which just means we've already given the computer the right answers to learn from.
It's really just the classic teacher-student analogy in action. You show a kid a picture of an apple and you say, A is for apple. You do it again and again. Well, we do the exact same thing with a machine. We feed it labeled data, this is an apple, this is a ball, this is a cat, until it starts to see the patterns all by itself.
You literally see this at work every single day with your email spam filter. The goal couldn't be simpler. Is this new email spam or not spam? The model was taught using millions of old emails that people like you and me had already marked as spam. Over time, it just learned to connect the dots, to see that words like congratulations or weird-looking links are huge red flags for spam, and now it can make that call for you.
Now, inside of supervised learning, models basically have two main jobs they can do. The first is called classification, and the second is called regression. Again, they sound technical, but I promise the difference is super easy to grasp.
On one side, you've got classification. Think of this as just putting things into buckets or categories. It answers the question, what kind is it? Is this email spam or not spam? On the other side, you have regression. This isn't about buckets. This is about predicting an actual number. It answers questions like how much or how many, like figuring out the exact price of a house. Okay, it's time to connect all these dots and actually put regression to work. We are going to build our very own pizza price predictor using a really simple but powerful type of regression called linear regression.
So here's our business problem, our big question. Can we actually predict the price of a pizza just by knowing how big it is? It's a simple question, right? But it's perfect for showing how all of this works in the real world.
All right, first things first, we need some data. Let's say we just called up a few local pizza shops and gathered some basic info. We've got the pizza's diameter, that's our input, the thing we already know, and we've got the price, that's our output, the thing we're trying to predict. In data science speak, we'd call the diameter our x and the price our y.
So, the heart and soul of our linear regression model is an equation I bet you remember from school, the equation for a straight line. Here, y is the price, x is the diameter. The model's whole job is to figure out the perfect values for m and b, the two magic numbers that will draw the one single line that best fits all of our data points.
So, after the computer runs the numbers, it calculates that the slope, m,
is 1.5. What does that mean? It just means that for every extra inch you add to the pizza's diameter, the price tends to go up by about $1.50. It also figures out the intercept, B, which is just the starting point for our line.
And just like that, we have our model. This simple little formula right here, that's our prediction machine. It has officially learned the relationship between a pizza's size and its price, all based on that little bit of data we gave it.
Now, for the really fun part, let's put our model to the test. A local shop wants to start selling a brand new, giant 20-inch pizza, but they have no idea what to charge for it. Well, we can use our model to give them a really good starting point.
All we have to do is plug 20 into our formula where diameter goes. So that's 1.5 times 20 minus 2, which gives us $28. And there you have it. We've gone from just a few data points to a concrete, data-driven recommendation. Pretty cool, right?
Okay, but here's a quick, important reality check. In the real world, data is messy. The points are never going to fall on a perfectly straight line. Our model gives us the best possible guess based on the overall trend, but the actual price of a pizza might be a little higher or a little lower. That small difference between our prediction and what's real, that's what data scientists call error, and the goal of any good model is to make that error as tiny as possible.
So there we have it. We started with the data you create every single day without even thinking about it, and we ended up predicting pizza prices. It just goes to show you that the heart of data science isn't always about super complex math. It's about asking the right questions. Which leaves me with one final question for you. With the right data, what could you predict? Thanks for watching.